This is Geometry Practice Test 8. In number 1, we're asked to find sine of x, which means our angle of reference is up here. Opposite of that angle is 24, so we're going to label that O for opposite. Opposite of the 90-degree angle is going to be 40. We'll label that H for hypotenuse, and the remaining angle, or the remaining side, sorry, is the adjacent. So let me go ahead and write our SOHCAHTOA. SOHCAHTOA. And we're asked to use sine, so I'm using sine over here. I'm using opposite over hypotenuse. Opposite over hypotenuse is going to be 24 over 40. 24 over 40. And I'm going to reduce by dividing by the greatest common factor. I think 8 is the biggest number I can divide by. And that's going to be 3 over 5. And let's check the back. 3 over 5 for number 1. 3 over 5 for number 1. And those have been circled for whatever reason. 3 over 5. Excellent. And in number 2, we have a tangent function, so I'm doing x though. So if my angle of reference is x, opposite of that is 24, hypotenuse is 30, adjacent is 18, and I'm using tangent, I'm using TOA, I'm using opposite and adjacent. So I'm using opposite and adjacent, I'm using our 24 and 18. 24 over 18. And I'm going to divide by 6, I think in this case. Divide by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. And we get 4/3. Let's go ahead and check it on the back. 4/3, we did get it right. Number 3, we're trying to find the measure of this angle. Again, opposite of our angle is going to be 157. Adjacent is 42. And hypotenuse is opposite of the 90-degree angle. We're not using hypotenuse in this case. So if I rewrite SOHCAHTOA so it's easy for me to see. SOHCAHTOA. I am not using the hypotenuse. I'm not using the hypotenuse. I'm not using the hypotenuse, which means I'm using the tangent function. Set it up. I say tangent of my angle always. Tangent of my angle in this case is question mark, and that's going to be equal to the opposite over the adjacent. 157 over 42. 157 over 42. And then from here, I need to solve for this unknown angle. So I need to undo tangent on both sides. The way that I do that, let me go ahead and move this over to the right so I have some room to write. I'm going to take the arc tangent of the left-hand side. I'm going to say arc tangent of the left-hand side. If I do it to the left, I also have to do it to the right. So I'm going to write arc tangent of the right. And in theory, these cross off, leave me with the angle. And the angle is going to be arctangent of 157 over 42. Let me get my calculator up here. And we'll just do a split screen, I think. So if I go to tan to the -1 is the same thing as arctan, if you've forgotten. So I'll write that up above. This is the same thing as tangent to the -1 of something. And I'm going to type in 157. My calculator, 157 divided by 42. That's going to be 75. So I'm trying to remember what we're rounding to in this. Round to the nearest degree. So 75 is the nearest whole number. So 75 degrees is my answer. Do you need to have that degree symbol? Not yet. Once we hit the unit on degrees and radians, then I'm going to be more of a stickler about if you're putting your degrees there. What about number 4? So again, I'm going to label my triangle the best that I can. Opposite of our angle is down here, adjacent is 21, hypotenuse is 22, and I'm not using the opposite in this case. So if I'm not using opposite, cross off opposite, opposite, and I'm using cosine. So I'm going to be using cosine of my angle. My angle is question mark in this case. And that's going to be equal to, cosine is CAH, so it's A and H. So it's going to be 21 over 22. Why did I leave so much room here? Because I know I'm about to take an arc cosine. So I'm going to now do that. I'm going to say arc cosine of the left and arc cosine of the right. And these arc cosine and cosine cancel each other out, leaving me with my question mark isolated. And I'm going to type in arc cosine over here in my function. So cosine to the power of -1 is the same thing as arc cosine. 21 divided by 22. This is going to be 17.3. 17.34, and I round that to just 17 degrees. And I should be checking my work. So 75 and 17, 75 and 17, we got them right. Let's move on to number 5. So we're trying to find the missing side length. So again, label your triangle with O, A, and H. I have opposite of 20 is the 17. Hypotenuse and adjacent. I'm not using hypotenuse in this case, which means I'm making this, I usually go by sound now. I'm using the OA. It's not SOA, it's not COA, it's TOA. It's TOA like this. So that's going to be tangent of my angle, which I do know this time is 20 degrees. I'm not going to put the degree symbol in there. I'm going to be lazy. And that's going to be equal to the ratio of O over A of x over 17. The way that I solve for x to get it by itself, I'm going to multiply the right side by 17 and multiply the left side by 17. The 17s on the right will cross cancel, and I have my answer. X is equal to 17 tangent of 20, which I can type in right now. So I'm going to say 17 tangent of 20. And I get 6.187. What are we rounding to? Round to the nearest tenth, it says. Tenth. So one decimal place. So this is going to turn into 6.2 for my final answer. What about for number 6? For number 6, I'm going to label my opposite of 71 is down here, adjacent and hypotenuse. In this case, I'm not using the adjacent. I'm using the opposite and hypotenuse. That's the O sound. Is that so, co, or toe? And it's so, because it's SOHCAHTOA, so it's so from SOHCAHTOA. That means I'm using sine of my angle of 71 is equal to my opposite over my hypotenuse, my 17 over my x. And to solve for x, I'm going to switch these diagonals, and I'm going to get x is equal to 17 over sine of 71. And I just type that into my calculator. I say that this is about what? It's going to be 17 divided by sine of 71, and I get 17.979. So I'm supposed to round to one decimal place, so this 9 is going to go up to 10, which makes this 17 and 18, and I have 18.0 for my final answer. Let's check these last two questions for number 5 and 6, 6.2 and 18.0. Whoa, 46.7. I was off. What have I done incorrectly? Tangent of 20. I have messed up somehow. How did I get 6.187? Ooh, I've made a mistake, which means if you pause the video right now and find the mistake before I do, you get some extra credit. Let's go ahead and check what we did. When we set up our problem, we had O and A. That looked good, so I'm using the TOA function, and it's going to be O over A. Oh my goodness, why did I do A over O? I did OA, or I did, no, it is O over A, but I don't know what sound that makes, but it's wrong, it's backwards, it's upside down. So this happens a lot. Good thing I'm checking my work. I don't know what I was thinking. I did A over O instead of O over A. So let's check this, let's fix this. All right, so O over A is 17 over X, there we go. And this one is also going to be a switching the diagonals, which means this 17 over here can go away. And I'm left with x is equal to 17 over tangent of 20. And now that I'm thinking about it, how would we have ever gotten a length? I think we had like 6, right? Does 6 even make sense for x? Like, these are usually drawn pretty close to scale. If that's 17, could something even longer be 6? And I should have done like a logic check. That doesn't make sense, so that had to be wrong. Let's try 17 divided by tangent of 20. 17 divided by tangent of 20. Okay, this is much bigger. So this is about, use my pen. This is about 46.707, which rounds to 46.7. And that makes sense. If this length is 17, this length looks like I'm doubling that, or more than doubling it. Doubling 17 is 34, and this number is more than 34. So that does now make sense. Is that right? 46.7? There we go. Okay, so we got the right answer there, and I already checked the 18.0. Good thing I'm checking my work. Whew. All right. Model, how to check your work. All right, these next 3 are the most difficult on the test, so pay extra attention. I'm going to pay double focus on these questions to make sure I don't make a mistake. If we do, it's kind of painful. There's a lot of steps. So I'm trying to get from 38 to here, and then from here to x. Again, we're just trying to get x. We're not trying to find an area yet. So again, I'm going to use this bottom side length to get this height of the triangle, and then from this height of the triangle to get this hypotenuse of the triangle. So let's extract this triangle on the left and see what's going on. I have this triangle on the left, which I'll attempt to sketch. And I have a length of 38, a length of something that I'll call y, and 66 degrees up here. So if this is my triangle, let's label my opposite, my adjacent, and my hypotenuse. Notice in this question, I'm not using the hypotenuse, I'm using the OA sound, so I'm using TOA. So let's set this one up correctly. I have tangent of my angle of 66, and it's O over A. It's 38 over Y. So it's going to be 38 over y, and then I'm going to switch my diagonals to solve for y. So I'm going to get y is equal to 38 divided by tangent of 66, and we'll see what the calculator says. 38 divided by tangent of 36, and I get 52. This is about 52.3. Again, everything is rounded to the nearest tenth. We're saying to do that for all of your work. So all of your work includes intermediate steps. I have 52.3. And now I can draw the next triangle. My next triangle is this triangle on the right-hand side that has a right angle here, 55 degrees down here, an X here, and we now know that the height is 52.3. So we're going to label our triangle with O, A, and H. O, A, and H. And from here, we're going to set up our function. We're not using the A, we're using the O sound, so that's SOHCAHTOA. So from SOHCAHTOA, I said that a little bit backwards, which means I'm using the sine function. Sine of my angle of 55 degrees, and that's going to be equal to opposite over hypotenuse. It's 52.3 over the hypotenuse of x. Again, when x is in the bottom, we're going to switch the diagonals, and I get x is equal to 52.3 divided by sine of 55, and we can get that on the calculator. I can say 52.3 divided by sine of 55, and I get to 63.84. 63.84, which rounds to just 63.8. I think that should be our final answer because we're just trying to find x in this case. 63.8 for number 7. Ooh, didn't get it. I'm making a lot of mistakes today, aren't I? Okay, let's go learn. What did we do wrong? Where's my double focus, Mr. Sindel? That's not right. And I'm already seeing the mistake. All right, pause the video, see if you can find the mistake. All right, here's the mistake. I'm setting up, the first thing that I saw was 52.3 doesn't seem to be the right length. If I'm going from 38 to something smaller, I have to get a number smaller than 38. I got a number that's bigger than 38. So the mistake had to happen right here. So what was the mistake that I made? I said that the, if my adjacent, no, I said that's my opposite and adjacent correctly. So let's see. Opposite of 66 is 38. Opposite of 66 is 38. That's the opposite. And then I'm putting my A here. Oh, it's a calculator error. You guys see over here, I wrote 36, and I should have typed in a 66. Now this makes sense, 16.918. So we can come back here and type in 16.918. 16.918, which rounds to 16.9. So 16.9 is the number that I'm going to be using over here. So switch this number out, switch this number out. This is all going to be wrong. I'm going to have 16.9. I should also label this one correctly. This is going to be 16.9 and 16.9. All right. I apologize for those of you that are stressed out about me wasting my time with mistakes, but I think it's also a valuable tool to find those mistakes. You can just use your eyeballs to figure out which one should be bigger and which one should be smaller. Figure it out from there, right? Go through the entire process again, and you'll eventually find it. 16.9 divided by sine of 55. That's the end of school. And I get to 20.6. 20.63, which rounds to just 20.6 for my final answer. Is that correct? I don't remember. 20.6. Now we got it. All right, we're on to number 8. Triple focus. Maybe I won't make a mistake this time. Let's see. I'm trying to get the area. If I'm after the area, first we're going to figure out what we need to know. I need to know the entire base, and I'm missing a piece of the base right here. So let's label that x. That'll be crucial information. We need base times height, and then we'll take half of that. Again, my area of any triangle, area of a triangle is always 1/2 of the base times the height. And we don't have the base, and we don't have the height either, so this height I'm going to call y. If we can find x and y, we can plug it into this formula, and then we'll be done. So how do we find x and y? Well, I can't jump to x yet because I need this length, or one of those two lengths to find x. So let's go ahead and find this length y, which is helpful for the height, and this length will therefore help us find our second length. So I'm going to redraw this triangle on the left so that I can analyze it a little bit easier. So I have this triangle, that's 38, that's a 5. Let's not make a mistake right now. Probably copied down the problem. 38 and a 43 degrees and a y. Labeling my O, A, and H. I have opposite, adjacent, and hypotenuse. I'm not using the hypotenuse, I'm using this OA sound, and that comes from TOA. It's from TOA in the SOHCAHTOA, which means I'm going to set my function and say that tangent of my angle of 43 degrees is going to be O over A, 38 over A, or in this case, Y. Again, Y is in the denominator. We've had a lot of variables in the denominator today, haven't we? We're going to switch these two. When we switch them, I'm going to get Y is equal to 38 over tangent of 43. And calculator. Let's make sure we don't have a calculator mistake. 38 divided by tangent of 43. And making sure it's typed in correctly. It looks good. So this is about 40.75, and we're rounding to the nearest tenth, so I'm going to round this to 40.8. All right, now we need our x. So how do we find our x? It's from this triangle on the right-hand side. This triangle, here, let me do it all once up so it makes the triangle look nice. This triangle right here, whoa, that was not very good. Try that again. This triangle right here has a 55-degree angle. We know that this is x, and we now know the height of the triangle is 40.8. So from here, I'm going to label the triangle with my O, A, and H. O, A, and H. And I'm using this OA sound again, so it's going to be a tangent. So tangent of my angle of 55 degrees is going to be opposite over adjacent, which is going to be 40.8 over x. Again, I have x in the denominator. That's happening every single time. That will not happen on the test. That's about 50-50 chance of happening. Switch to them, and I get x is equal to 40.8 divided by tangent of 55. And I'm going to type this in correctly. 40.8 divided by tangent of 55. And I get 28 point, this is going to be about 28.568. Let's round that to 28.6 because the number after the 5 is greater than 5. All right, so if that length is 28.6, let me label this 28.6 here. It was a 40.8 here, and we have all the pieces. So in order to find the base is going to be adding 38 and 28.6. I can do that without a calculator and hopefully not make a mistake here. It's going to be 66.6. Whoa, weird. And from here, oh, and I already made a mistake. 8 and 8 is 60. No, okay, I didn't make a mistake. I was worried there. So my base is now 66.6 times my height. My height is 40.8 times, I'll say 40.8. And that's going to be multiplied by a half. So we're going to multiply these all together and see what we get. 1/2 times 66.6 times 40.8. And that's going to be 1,358.64, which rounds to 1,358.6. I think we're running to the 10th in this entire problem. Please be right. I've made enough mistakes today. 1,358.6. 1,358.6. Let's go. And that was the easier of the two between 8 and 9. We have the penultimate problem on the test. This is the hardest problem on all of it because there's 3 things you need to find. When you find this length, and I'm going to call this W, this length as well. All 3 of these lengths are used in our area formula. So we know what the area formula is. We know that it's eventually going to be 1/2 base times height. We'll do that at the very end when we have very little room left, I imagine. All right, so let me draw this triangle on the left first. So this triangle on the left, to find, I'm just going to randomly be like, I want to find x first. If I want to find x first, and I know this length is 20, I'm going to ignore the fact that I'm trying to find w on the next step. Let's pretend I'm only trying to find x from 20. If that's the case, I have a 29-degree angle here, and I'm going to label this triangle. I have an opposite, I have an adjacent, I have a hypotenuse, and I'm going to make this sound that's the sound, the AH sound, which comes from not sa, not to, not ta, but ka. So it's going to be C-A-H from SOHCAHTOA. So if it's the ka sound, it's cosine. I'm going to say that cosine of my angle of 29 is going to equal my adjacent over hypotenuse, my x over my 20. And finally, I have a problem where the variable is not in the denominator. I can multiply both sides by 20, multiply both sides by 20. 20 are going to cancel out, and x is going to be 20 cosine of 29. I'm going to type in 20 cosine of 29, and I get 17.49 9, which is going to round up to 17.5. Okay, that's done with x, and let's move on to find w. So again, w is going to come from that triangle on the left, which I will draw yet again. And say, here's my triangle. I have a length of w that I'm trying to find, a length of 20. I could have labeled, instead of 20, I could have labeled this value that I just found down here, 17.5. But because 20 is precise, I'm going to do the work from a number that I didn't have to round to make sure I don't make any mistakes. So I know that I also have an angle of 29 in the bottom left, and let's label our O and H, opposite, hypotenuse, and adjacent. In this case, I'm using the O sound coming from SOH, S-O-H, which is going to be sine of our angle of 29. That's going to be equal to opposite over the hypotenuse, W over 20. And again, I just need to get rid of the 20 by multiplying by 20, multiplying by 20, and I get W is equal to 20 sine of 29. So I'm going to type in 20 sine of 29, and I get 9.69, which rounds up to 9.7. 2/3 of the way done in terms of the unknown quantities. Now is a good time to do kind of a mental check of, does this make sense? If this length is 20, this length is a little bit less than 20. 17.5 is a little less than 20, so that makes sense. This looks about half-ish, because this was almost a 30-degree angle, making this a 30, 60, 90. So it should be almost exactly half. So half of 20 is 10, and 9.7 is really close to 10. So that makes sense so far. I don't think we've made any mistakes. Finally, this triangle on the right, let's go ahead and redraw that. This triangle on the right looks like this, and I have a 90-degree angle here, 55-degree angle down here. I know this length is y, and w is 9.7, so this length is 9.7. All right, labeling our triangle with our opposite, adjacent, it's supposed to be an A, an adjacent, and a hypotenuse. In this case, we're not using a hypotenuse, and we're making the OA sound, we're using tangent, which is interesting because that means we're using every single function in this problem. So tangent of my angle of 55 degrees is going to be equal to OA of 9.7 over y. In this case, the variable is on the bottom, so I switch my diagonals, and I get y is equal to 9.7 over tangent of 55. And that is going to be, do I have enough room over here? No, so I'm going to say y is about, let's do 9.7 divided by tangent of 55. It's about 6.79, which is really close to 6.8 if I'm rounding to the nearest tenth, which I'm supposed to be doing at each step. Does that make sense? If I have 9.7, this length should be a little bit smaller than 9.7. 6.8 is really close to 9.7, but a little bit smaller. So that makes sense so far. Now I need to find this entire base. I need to do x plus y. Here's my y. Here's my x. I'm going to add these two numbers together. I'm feeling a little bit lazy, but I'm going to push myself. We're going to add these together, and my base, this is in black, my base is going to be 17.5 plus 6.8. That's going to be add 3 to 17 to get to 20, another 3 to get to 23, but it's going to be 24 because I can see that there's going to be a carry. 8 plus 5 is 13, carry to get to 24, and we got the 3. So 24.3 is the base. And then the height is W, so my formula is the area is equal to 1/2 of the base, which we just found, 24.3, times the height, which we know from W is 9.7. This is definitely a calculator problem. 1/2 times 24.3 times 9.7, and I get, this is equal to 117.855, which I will round to 117.9. There are a lot of steps. Please be right. 117.9. Oh my God, that's so satisfying. 117.9. The next two problems are pretty straightforward as long as you've memorized the formula. Let's see if I've memorized the formula. This is the way that I have remembered it, and if it helps you, congrats. If you just memorized it, even better. So I've always remembered it as area is equal to apothem times perimeter times 1/2. So I know that the apothem length comes from, here, let me just make sure I'm redriving this. Okay, the apothem length comes from this length right there, which is the apothem. So this is side length divided by 2, and then I'm going to divide that by tangent. So this is going to be side length divided by 2, and then also divided by tangent. And I remember this number is always going to be 360 over 2n. So that's the apothem length. And then perimeter is going to be s times n, and that's going to be times a half again, so 1/2. Or it's kind of a trick to just do 2 times 2 is 4 on the bottom, but I'll just type this in exactly. Pro tip for those of you watching the video, you can just enter this formula in as you see it with the variables. Check it out. S divided by 2 tangent of 360 divided by 2n. And this is going to be times s times n. I think that works if you just do sn and times a half. So I'll say times 1/2. And if I come down here and I type in what s is equal to, and I type in what n is equal to, I think this should work. The number of sides that we have, let's check it. We have 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. It looks like a stop sign. Just wanted to be sure. It's an octagon. And n is the number of sides, so that should be 8. This s is the side length. So it doesn't give us the side length, so I have to do a little bit of math. If the entire perimeter, if all 8 of these add up to 24, 24 divided by 8 is 3, so the side length is 3. And this should still give us the correct answer. So you still have to write out all of your work. You'd have to write out, okay, you're going to do s, which is, in this case, 8. S is equal to 8. N is equal to, wait, s is not equal to 8. I said s is equal to 24 over 8, which is equal to 3, and n is equal to 8. So I would, in my notes, I would say I'm going to do 8 over 2 tangent of 360 over 2n. All this times s, which is 3, times n, which is 8, times a half, which is what I have written down. And I did it in my formula, and this is going to be equal to, and I guess I'm approximating here. I'm going to round and say this is going to be 43.4558. What does it say to round to? Nearest tenth, so 1 decimal place, and this is going to be 43.5. Is that right? Please be right. 43.5. There it is. The nice thing about entering your formula in like this is you can just do it really quickly on the next try. Check this out. So in this case, I need s and n. S is equal to 8. It tells us it right down here. The side length is 8. And how many sides do we have? It looks like 6. 1, 2, 3, 4, 5, 6. So that means n is equal to 6. We do have to write out the entire formula once again and say 8 over 2 tangent of 360 over 2n. That's going to be times s times n times a half. But all we have to do in our calculator is we change s to an 8 and change n to a 6, and we should get our answer. It's going to be equal to 166.276. Right in the nearest tenth is going to be 166.3. 166.3. You'll notice that I left the units off. I feel a little bit guilty, but units sometimes help you to figure out what to do with your formula. This is not one of those cases, so I'm just going to ignore it. And if you put units on, good for you. If you don't put them on, I'm not going to take away points. With 2 kind of big errors on the front side, oh no, we made an error on the back side too. With 2 big errors on this test, there it is. Thanks for watching and sticking along with me, guys, and good luck on your test. I'll see you guys later.